Okay. Yeah, my hackathon was about data space onboarding with Gaia-X credentials. Yesterday we already had, or let's say we start with the data space itself. So we all probably now have a common understanding of what a data space is, but I want to remember that a little. So usually a data space consists of a number of participants. They all can have different roles. They can be data providers. They can be data consumers. There are marketplaces and so on. And all those organizations, so the participants are usually organizations, also have employees or services and so on that act on behalf for these organizations. And the data space itself enables the connection between those services based on a common trust anchor. In most data spaces, there is something called a verifiable data registry. Sometimes it's called trust anchor, participant registry, trusted issues registry. I think the concrete name is still a little debatable. But there is this kind of central entity that holds the number of participants in a data space. Now, this is all nice and shiny as long as everybody is already in the data space. But it's quite common that a new participant wants to join the data space. And this participant then needs to be somehow added to this central registry so that all other participants can verify that somebody connecting them is actually coming from the new participant. But what does it mean to join a data space? So usually you have a set of entry rules for a data space that should be fulfilled. So for example, you have a data space that should be obviously Gaia-X compliant. You want to have only participants from a certain region. You only want to accept participants from a certain domain. Let's say you have a health data space, then you maybe only want to have medical entities joining. Then you might have terms and conditions for a data space that need to be accepted to actually work in it. And you might have to sign certain contracts so that you're allowed to enter the data space. Traditional, we do this by signing some documents, sending that to someone. Somebody has to check them. I'm not sure whom of you have seen the simple presentation in February. They had exactly that example. Somebody had a PDF, it was signed and then sent per email, and then somebody had to check it, and they were accepted to the data space. My thought was that if we do data spaces that way, that's wrong. So we now need to find a way to automate away this whole process. So the solution in our technical environment here is to go away from the PDF and actually use verifiable credentials. The verifiable credential is a document that is signed, and it also provides claims about the organization that we have. We need to put some trust in those credentials. That's what we could use the Gaia-X digital clearinghouses for. The Gaia-X digital clearinghouses can take those credentials, then check their compliance and issue a compliance credential for this. We then can use essentially both of those credentials together for gaining access to our data space operator. I will come to the picture below next steps. In addition to that, we could codify our rules for entry into the data space, not in a list that we have to check, but actually an ODRL policy that we can evaluate and also enforce to allow the entry. And then as a last step, we could leverage standard protocols like OpenID for verifiable presentation to exchange the credentials between our new participant and our current data space so that we can actually allow a self-onboarding. If you take a look at those pictures, we essentially have our data space. All the participants are connected to the Trusted Issuers Registry and trusted participants that are registered there. We now have an entity that we call here a data space operator. It's essentially an organization, a body, whatever, that runs the data space itself and takes care of operating the issuers registry and also taking care of onboarding new participants. For self-onboarding, it essentially provides an authentication facility and an authorization facility. The authentication part is the verifier. The verifier gets the verifiable credential from the new participant, essentially two in our case. So we use the legal person credential in the example together with the compliance credential. The verifier checks obviously the signatures of those credentials. And for the compliance credential, it also checks that it comes from a registered Gaia-X digital clearinghouse. So we can check the whole trust chain for this credential. Then we have to obviously check the signature inside the hash code inside the compliance credential, that it belongs to the legal person credential, and then we can trust this credential. Out of those credentials, we condense some information and return back a JWT token to the new participant. With this token, we then contact the trusted issuers registry again through our policy decision point. The policy decision point then can evaluate the ODRL rule that we created and decide automatically to allow the addition to the trusted issuers registry or deny it, depending on our contents. Now, how does it look in an architecture view? Most of the components that we have here are essentially from the Fiber Dataspace Connectors IAM framework. So we have from the authentication framework, we have the verifier, together with the component called credentials config service, which allows very fine granular definition of what credentials to be requested and what should be extracted from those credentials to be put in a JWT token. And we have the authorization framework, which follows essentially the PXP architecture that we all know from policy decision and enforcement. The role of the policy enforcement point is taken by API6 here as an API gateway, which requests the decision from the open policy agent, which will be the policy decision point. And the policy decision point gets its policies from a component called ODRL PAP, which takes ODRL policies and translates them into REGO, which can be evaluated by the open policy agent. Now, in the presentation before, I now did a live demo. Due to time constraints, I cannot spin up the whole system, but I can walk you through the idea of the live demo. And I encourage you to go to the Hackathon GitLab repository because everything is written there so that you can essentially replay every step on your local machine. For the live demo, or for the local demo, I've set up a local Kubernetes cluster using K3s and deploy a provider, which should act as a data provider, having authentication capabilities. Then a new participant, which essentially consists of its identification. So it presents it's the JSON document, which it's the web and so on, all that we need to verify the participant. And also I deployed a key cloak for this participant, so it has the capability to issue verifiable credentials to its employees so that they can act on the data space afterwards. And obviously we also have the trust anchor between both of them with the architecture that I presented. So now it probably is not as impressive as it could be when I just walk you through the calls. But essentially what we do in the demo interaction first is trying to get a credential for our user and then exchange it for a JWT token at our data provider. Since we're not part of the trusted issuers registry yet, we will just not get an access token and cannot work with our data provider. To do so, we have to prepare our self-onboarding service. We essentially have to prepare two services for that. We have to tell our credentials configuration service what credentials to be requested and also how to verify them. So we request a credential of type Gaia-X legal person because we want to rely on the legal person credential. And we also tell it that we want only to use those four claims from the credential inside our JWT token. That's technically important because, as at least the technical people here know, JWT tokens are quite huge. Verifiable credentials are quite huge. And since we want to use an access token that is derived from it, we would run into the limitations of having an authorization header if we just use the full JWT token credential. So we just extract the information that we will need for later decision making. In this case, we just take out the legal address, the headquarter address, the credential type, and the issuer, because that's all we need for our decision making later. Okay, now let's assume we have configured that. We also have to configure our policy. This is an ODRL policy, as maybe some of you already know. The ODRL policy consists of, in this case, 4 key elements. One is the target. We limit essentially the application of this policy to assets under an HTTP path. We defined a left operand for that, which is called HTTP path. And it needs to be /issuer. So only calls to the issuer endpoint are allowed. We also want that those people can do self-onboarding. So they get allowance for the action ODRL use. Not only read, for example, but with use, they are allowed to create new entities. Then we have to limit the assignee, so who is allowed to use this policy. In our case, that should be the issuer of our legal person. So the legal person should only be able to add itself to the trusted issuers registry and not other entities, because we only have the information about this one. So we are using the OVC left operand to extract the issuer from the verifiable credential and compare it with the issuer that is mentioned in our registration request. And we put on a fourth constraint, essentially to have an example for our onboarding rules, where we put on an OVC constraint. And in this data space, we only want to allow companies that reside in certain regions. In this case, it's somewhere in France and in Belgium. And we require a verifiable credential here of type legal person, where the country subdivision code of the legal address is either this or that. And with all of that, we can make an automated decision on allowing the people to the data space. With that set up, I can skip this because this is really not very interesting if you just read it. But essentially, we create a verifiable credential and sign it. Then we encode it as a verifiable presentation, which again is only interesting for technical people. We exchange it for an access token, essentially the JWT token that we talked about, which only includes the types, the issuer, and also the address. And then we use this access token in this request. And this request essentially means, okay, I have my access token, and now please add my DID to the trusted issuers registry. That's more or less everything to be participant of this data space. And with this done, we now could theoretically repeat the access token exchange and get an access token from our data provider and access the data. Yeah, that's essentially it. I can now open for questions. I'm not sure how long. Or